All right, good afternoon. Thanks for joining the session, and thanks for holding on. We had a little bit of a technical difficulty, but we're able to keep going. My name is Alfred Ojukwu, and I have my ghost presenter, Frank Pinto. Everybody say hi to Frank. I'm just kidding. Frank has done this presentation with me before. However, on his way here from Europe, he got caught up with PSA. He had 7 devices. He's kind of stuck there now. No, I'm just kidding. Yeah. Frank is in the UK, so I'll be doing the presentation, a demo by myself. However, in Europe, if you end up in Europe, he'll also be there as well. So just keep that in mind. So I'm going to go ahead and jump into the presentation. This session is replacing BIOS with the UEFI deployment. It's all about Windows 8. It's all about the BIOS. It's all about the UEFI. So before we get started, if you're in the wrong session, please feel free to go ahead and head out. You don't have to give bad evaluation because you didn't know what it was about. But this is about UEFI. So let's go ahead and get started. So first question for the audience. Can somebody tell me what the similarities are between these two vehicles? That's Mustangs, orange, 4 wheels. Lots of good guesses. For anyone that said Mustang, for anyone that said orange, and for anyone that said 4 wheels, you're right. You're all right. Now let's go on the next piece of this. What are the differences between the vehicles? Age, speed, performance, horsepower. All of those answers are correct. You guys pretty much just went through my whole presentation with just one slide. The difference between BIOS and UEFI. So we're talking about, this session is really going to cover the existing firmware platform that we know about, and we're going to go into an introduction of what UEFI is, why it's important, why it fits into the architecture of your deployment, your operating systems, and then we're going to talk about configuring in UEFI. Now again, this is primarily to demo what UEFI is and how it works, and not necessarily to focus on the idea of this is what my deployment is going to do ultimately. And then we'll talk about some additional UEFI-based features, and lastly, we'll come up with a summary and close out with any questions you may or may not have. So for those of you watching on board, there's maybe some conversation going on in Channel 9. I've seen a few things. My ghost presenter, Frank, has probably already answered some of those. So just kind of keep an eye. And as we go in, hopefully we can get through the 75 minutes. There's a lot to talk about. I'm going to do my best to make sure we cover as much as we can. But I can't cover everything in 75 minutes. So without further ado, we'll go ahead and move forward. And the first question, how many people know what this is? What is this? Wow. So this is a really cool device. Why is that? So exactly. It's an 880. It was probably one of the first few systems that existed, multiprocess, that had the ability to sort of process information. And when I worked for the government about 18 years ago, right, we actually had one of these. We actually used it. But the problem with it, as I mentioned, is it's manually controlled, laboriously slow, at least from what we know of, and error-prone. But back then, it was probably the best thing since sliced bread, right? So again, right back to the car scenario, we have an old device that's supposed to do some magical things. However, because of the age, I doubt anybody's probably running in their data centers today. So that's the precursor to the BIOS. Many of you guys already know this screen. This is what we typically see day in, day out when we're working with systems. We're well aware of what the BIOS infrastructure looks like, and the fact that it is somewhat, the basic architecture that we've already known and what exists today. So it basically allows you to manage the OS and prepare the system for actually booting and using the hardware itself. So this is what we're used to. This is what people know. It's what started the whole process of initializing the firmware and ensuring that it's actually available for the OS. So this menu is what we look at when we're talking about getting things updated. And the important thing that I wanted to show here is the fact that it's something that we're familiar with. However, it's there because it was the only thing we could use to manage the initialization of anything, the option ROMs, anything that had to do with the hardware, so that you could actually get to the applications themselves. Moving forward with that, if you understand the basic BIOS boot process, what you start seeing is, the CPU, the fact that it executes the code and it goes through the process of the post. Most of you guys know we're looking to sort of speed those things up and increase how those things work. Oh, the screen didn't actually change, but I'll go ahead and do that for you. Boom, there we go. And we're moving from the initialization of the LAN itself, the PCI card, any option ROMs you have available, and moving into sort of how do I find my bootloader? How do I make sure that partition's available? And ultimately passing it to the bootloader so that you can actually boot your system up and run the operating system. The ultimate goal, again, goes back to the fact that you're still using that older BIOS system, and you're still running Windows, and it's still doing what it needs to do. Now, again, that's not the point of the presentation. That's really to give you sort of a historic understanding of what exists today and where we're going tomorrow. So a basic boot flow process, for those of you who didn't see it, going from the hardware device, the device controllers, firmware becomes sort of the main location where that information is sort of initialized and moved over to the CPU, and then passed over to the software itself, and which ultimately owns the use of the application itself. The most important piece here is that without that firmware, we can't initialize anything. We can't get anything running. But it also controls the communication that happens to the hardware. The challenge we have is we need to really think about overhaul. So in the mid-70s, again, going back to that orange old vehicle we had, the challenge we had was that at that point in time, a lot of this technology was fairly new, it was fairly broad, and we start seeing that the BIOS is now over 30 years old. It needs a rehaul. The 16-bit assembly mode, becomes an issue. The hardware limitations that were causing delays. I mean, and we'll talk about that as we go into UEFI and some of the changes that we see there. And we start seeing that the option ROMs are limited, or at least they run fairly slow. You're limited by the memory availability, and lastly, just the modularity in itself, as you saw on the BIOS screen, sort of slowed things down. And last but not last on the list is just securing the pre-OS environment, ensuring that you had a complete process from the time you press the button all the way to the time you actually utilize your system, knowing it was secure. You couldn't truly do that with the BIOS unless you had some sort of additional conversation with your OEM, or they provide you additional software that actually protected that location. And that required a lot more engineering than you probably had. So moving forward, has anybody familiar with assembly code? What? I wouldn't be surprised. That's really cool. So one of the biggest difference, and one that I kind of find interesting, is just the fact that if you're looking at BIOS, the fact that it's written in assembly language, and you're still using things like interrupt 16, interrupt 13, interrupt 19 to be able to kind of convert that information so that it's usable on the system. And with UEFI, we see sort of that improvement in the underlying architecture of the BIOS, so the pre-OS environment. Now, can anybody tell me from what time period is this from? 1990s. Anything exact? Any more exact? Anybody think of anything? 93, 97. A lot of stuff was going on. What particularly do you know? What's one of the most important things you notice here? What are some of the things that you notice here? Just throw out anything. NT4. That's pretty cool. So yeah, a lot of stuff was going on at that point. So the biggest thing that we start seeing is we see new technology, new music, new movies, new music, and new technology. that's probably what happened. So what we start seeing is in the mid-90s, Intel decides they need to think about how they're dealing with the boot process because it had been aged. It had been sort of overused, if you may. And Intel starts the process of looking at how they can utilize the Itanium to kind of boot to a newer boot into the operating system that was a 64-bit operating system. They needed the rewrite that needed to happen. So the EFI came about, so Extensible Firmware Interface. So I have up here Unified Extensible Firmware Interface, but prior to UEFI, it was called Extensible Firmware Interface, and Intel kind of owned that process of making sure that code was updated and managed. So in about 2000 or so, they were able to write the first, to release the first code for specifications for EFI, which is 1.1. And that became sort of the standard. People were excited to have that ability to use EFI as a framework to deliver the OS. And as we kind of move forward, UEFI, which for those of you guys aren't, you guys can probably pretty much read, UEFI, Unified Extensible Firmware Interface, gave them the ability to have a solution that was agreed on by a consortium. So it allowed for the use of specific codes that actually worked across the EFI system, and it provides support for newer hardware. Again, that's where it's able to address the 64-bit platform. It's able to allow you to boot in the pre-OS environment and just allowing you to secure the pre-OS environment as part of the boot process. So huge jump. So that was around 2000, 2002. We kind of moved into the stage of EFI and determining whether or not it was actually going to stick around. And with that, Intel decided to give up the code to UEFI, who then, to the forum themselves, who then sort of created this consortium of folks that were responsible for managing the code itself. So Microsoft, you see Dell, you see a lot of you guys who probably work for the organization. A lot of your organizations are part of the firmware participants. So as you can see, we have a number of promoters, we have a number of contributors and adopters, and a number of different working groups. Each one of those working groups have a specific role, a specific task within the forum itself, but all in all, their goal is to ensure that pre-OS environment is configured in a way that allows you to provide secure, reliable, and faster systems using the newer code. So what are the advantages of UEFI? And as we get through this, we're going to dive right into the slides. I'm going to get to it. So some of the advantages you start seeing is it enables innovation. That you guys are aware of. It really just allows us to sort of extend what we're doing with the pre-OS environment, things that we couldn't do before, like allowing secure boot, which didn't exist in the pre-OS environment, and ensuring that we're able to kind of secure that process, that boot process. We also start seeing the ability to use large disks. We go from the limitation of having a 2 terabyte limitation on BIOS to going above that. So we end up to about 9.4 zettabytes when we start using GPT disks. We're moving from MBRs to GPTs as well. And we start seeing the fact that you no longer are dependent on the CPU itself. It has its ability to kind of manage it on its own without the CPU being the dependent piece of physical infrastructure that's required for it. Furthermore, you see that the pre-OS environment is much more flexible. You can do different things with it. You can have different components built into it, and just extensibility that kind of increases the overall use of the pre-OS environment. And lastly, the modular design. So if we remember the BIOS, that single screen, we can now have different designs for the pre-OS environments, which we'll look at when we get to that demo. And the important piece here is with the advent or with the addition of UEFI, what you start seeing is you no longer have to be dependent on just BIOS. And as we move through the different classes, you're moving from not just having a BIOS infrastructure that relies on the MBR architecture. You can now utilize the EFI to register the ACPI drivers, to be able to use the Windows OS environment that exists today. So we definitely are seeing a firmware evolution, if anything. So now we're getting into the heat of it, the UEFI boot process. This is, I don't know how much people we actually get into the boot process, but this all happens within a certain amount of time. Just out of curiosity, anybody familiar with the specified time that is allotted for the boot process to happen in UEFI? Yes? So about, I see one finger, two fingers, the peace sign, right? About 2 seconds. This whole process is literally supposed to happen in 2 seconds or less. That is the specification, and it's based on the fact that they standardized the architecture, they standardized the requirements on what needs to happen throughout the boot process, and the fact that they're able to use more memory to actually do the boot instead of just using the memory headers. So you can see here it goes through the security phase where it actually does the pre-verification, and then moves on to the pre-initialization phase, going through and initializing the CPU, anything that has to do with the board. It does all the initialization and then moves into loading the drivers. Yes, now you can have drivers as part of your DXC or driver execution environment as part of your boot process. So this goes back to that CPU-independent architecture. Now, because that process happens so rapidly, quickly, there's no way to physically say, there it is. It's happening right there. As we go through the demo, I'll kind of show you, where that happens, where that actually is occurring, and that way you get an idea of what's going on. And lastly, you move into sort of the passing it off to the boot manager, boot megger, I never liked the name, and using the UEFI interface where you actually see that process of the pre-OS build. And then lastly, you move into handing it off to the OS loader. Once it finds the partition, it hands it off to the OS loader, and then it kills that execution in the runtime environment, the EFI environment, and moves off to the OS. And at that point, you're really it's passing it off to the Windows, and now you're moving forward with the actual boot process. Now, those are the similar. You kind of notice the similarities. We talked about differences and similarities, but those are the similarities. Some similarities you've noticed already still exist in the BIOS, the fact that it still has the same basic functionality, which is to be able to initialize the CPU and pass it off to the bootloader. And again, you see where it sits in this whole process, the fact that it goes from the hardware, the firmware. We always call it the BIOS, but it really is the firmware, and it passes it off the operating system and over to the actual application that runs on the system. So now that I got the PR piece out of the way, we can actually get to having some fun. So I'm going to switch slides here. And we're going to take a look at basically just the disk partition table. So I'm going to switch really quick. We're going to take a look at that just so you guys can see what's going on. And we'll talk about where it fits into the process. Let's see if I can move over to the right monitor, and we'll move forward. All right. Let's see if I can duplicate this and see if that shows up there. So what I'm going to show you really quick is, as soon as I have that screen, is the screen that has the disk partitions. And I'm not seeing it show up here. No, this one. This one. Mm-hmm. All right. Mm-hmm. So, is it plugged in? Okay, I'll plug it out and put it back in. Hang on, guys. All right, so we're going to check it one more time. There we go. We have our screen. Yay. All right. So really quick, we're going to show how can we tell. So we're going to get into the Windows, the actual UEFI deployment. But we're going to take a look at the disk. How can you tell if you're actually running a UEFI-based system? And that means I have to switch this screen so you guys can. Duplicate. And doesn't duplicate. So I'm going to extend it and move my screen over. I'm going to move my start menu over to that side so you guys can both see it. Let me know when you can see the screen. All right. All right, so what I'll do is I'll just move the disk over to that side, and that way you all can see it. There we go. We'll start here. So I have a disk with a partition on it. This machine was built on UEFI. This is a Lenovo W520. So most of these systems already come with the ability to use UEFI. And I want to show you the disk partition, and we'll go back into the system itself. So I have a disk partition that already that's already been formatted with the UEFI specifications. And I'm going to go in here and basically go into the properties, and we show the details. Where is it? Are blank. This is awesome. They're perfectly blank. You won't be able to see it there. So the other option when you can't see it there is you definitely want to be able to go into MS Info 32 to see your hardware configuration. It's able to tell you whether or not you're in BIOS mode, and here it'll actually show you that you're in BIOS mode, and you can actually use that as an option. There are other tools out there that are provided by the vendor themselves that allow you to go in and determine what type of hardware am I running, or what type of disk am I running, has it been formatted correctly, and can actually use it to do what I want it to do. Next piece here is we're going to take, one of the steps that's required for creating an image is actually going through the process of creating that boot image so that it actually can boot into a Windows 8 system. We'll come back to that, but I want to show you really quick, another way to look at your disk and determine whether or not it's ready for UEFI or not. And I'm going to do that using diskpart. We'll just pull it up here. I have 2 disks in here already. And these 2 disks we'll be using later on, disk 2 and disk 3. And if we list the volumes, we'll also be able to see the makeup of those disks. One's NTFS, one's FAT32. And when you're building your image, those 2 are required. Now, that doesn't tell you a whole lot about UEFI, but it just lets you know that you need at least 2 different types of partitions to do it, or possibly 2 different disks. So we'll come back to that, but the key here is make sure that you know what type of operating system, what type of disk you're using, and the fact that UEFI relies on that GPT partition. The GPT partition is the key aspect in making sure your images actually run the way you want it to. I'm going to switch back over to number 8. All right. So right now, what I have, I'm going to go ahead and reboot this really quick. There's all my screen prints from going back and forth on the machine itself. Pretend you don't see that, but it's really cool. It still works. So I'm going to boot into the boot option. Another important piece, we talk about UEFI. Hopefully we can see this. Let me move this over just slightly. Perfect. Now, you have your options. When you're first setting up your systems, you need to think about how that system has been built. Most of the newer systems are now coming with UEFI enabled by default. Windows 8 comes with UEFI enabled by default systems. And also, the Windows Surface Pro is also UEFI by default. So we call it a Class 3 system, meaning that it doesn't have the option to switch back to the older BIOS that you guys see in some of the other systems. It's just literally you have to run it on UEFI. That's a Class 3 system. We'll talk about that as well. And first thing you want to do is make sure that you're entering the setup itself. Make sure you're taking a look at whether or not you're enabled for UEFI itself. And I'm going to do that here. So you'll notice here you have two options. You have Legacy Boot and UEFI Boot. Now this is a Dell XPS 12. As you probably know with the modularity, all the systems won't be the same. This just happens to be one of the systems I own. And unfortunately, because I'm a Microsoft employee, I couldn't get a Surface Pro. So if anybody wants to let me borrow it, I have an envelope. I can give it to you later. Just kidding. Anyway, so important piece is the UEFI is an option that you can actually use. And you have the option to enable it. Make sure it's enabled. You cannot, if you're going to try to run anything that's UEFI based, make sure that you have UEFI enabled. And secure boot as well. If you go down to this list, you have a list of options. It automatically, if you turn on secure boot, you automatically get, I'm going to go ahead and disable it. It still lists boot list options, UEFI. You can have legacy or secure boot. We've already selected UEFI. That's to ensure that we're able to use the secure boot and TPM as well. Now, one thing to note is that UEFI does not rely on TPM. So if you have a system that doesn't have TPM, you could possibly run UEFI still. However, for secure boot to run, you need to have TPM available. So it's kind of a gotcha. You want to make sure TPM is available. You want to make sure you have UEFI running. You need to make sure that's going to make your system secure. It also, and we'll talk about the sign hash and other aspects of this. So we're going to go ahead and enable this. So here's your option to enable it. Make sure you have UEFI as an option. And that's pretty much it when you're setting up your system. Those are the two main things. Now, I'm going to go ahead and exit. I'm going to assume that none of the changes need to be made. I'm going to say exit because the system's already there. And I'm going to boot up into my system with a device connected to it. And it's so fast, I didn't even catch it. Okay? Let's see if I can catch it one more time here. All right, perfect. So we're booting up into the same path. So I have a USB device here that has two partitions, an NTFS partition and a FAT32 partition. And I have my boot manager available as well. Normally, if you're going to build a whole new system, you want to make sure that you have that USB path available so you actually can do it. So you actually can boot to that partition using EFI. I'm going to leave it there for a second. We'll come back to that in a later slide so we can go over kind of what we're doing and how that's actually working. Let's switch back to our presentation mode if I can find it. Yay, found it. All right, so when you actually create your disk, or whenever you are actually building your systems, you'll notice that you'll have a number of partitions that are created. One for the EFI, one for the MSR. And with the grid partition table, you have a literally limitless number of partitions that can actually be created. With MBR, you're limited to 4 partitions. However, for backwards compatibility, you'll notice that on the GPT disk, it'll have a protective MBR that basically fools it and tells it don't use this disk because it's not MBR. Your system has to be GPT, and GPT is just much more reliable partition table because you have the ability to back up that data, and if you lose a partition, the data is always available. So it requires that as an available component within GPT. I believe I showed you this. Mine didn't have images, partially because maybe the system didn't come up the way it needed to. But if you're looking at it right, you'd see that it's actually labeled as a grid partition table. In addition to that, you'll notice that you'll have the different partitions that are available. You have the EFI partition, the MSR, which you probably can't see. We have a recovery partition that's provided as part of Windows 8. So when you're doing your imaging, that recovery partition will actually be built into it as well. And then you have your normal primary partition that's actually used for the OS. So Microsoft's recommendation. We talk about what your system should look like. We have a Windows recovery partition. You have your EFI system partition, like I just mentioned, and the Microsoft Reserve partition. Each of these partitions are there to sort of have sort of a scratch base to be able to use for different things. The system partition primarily is used for EFI. So you'll see your boot files there. You'll see all those settings there. You'll be able to use it there. And it's the default configuration. If you're going to do any sort of image recovery or management of image, you probably want to use your MDT image to actually, MDT task sequence, to create an additional partition that allows you to do the recovery. And this, both of these are best practice configurations depending on what you're trying to deploy. Again, the disks are what actually make a difference, so just make sure you're paying attention to that as well. Let's go ahead now and go back to creating that bootable USB. The options that we have available for this is you can split that WIM. So if you're building your image and you have a WIM file, boot the install.wim file, and it's too big for that initial NTFS partition, or a FAT32 partition, and it's not big enough, you might want to think about splitting it off into a SWIM file. And there's multiple ways to do it, but what it does is it allows you to have the content stored on a single disk or a single USB, and then have additional content ported over to a secondary or tertiary USB. You can create multiple partitions on your Windows to Go USB drive, which is kind of what I'll show you guys here when we get to the actual viewing of that process. And then you can create your image using 2 USB sticks, which we'll build momentarily here as well. So there are a number of options. Another one that I haven't mentioned is if you are using Windows Server 2012. So Windows Server 2012 also gives you the ability to pixie boot into a UEFI, using UEFI, on either 32-bit or 64-bit. Windows Server 2008 allows you to do it for 64-bit. And 2003 does it for the older EFI technology as well. Okay? And lastly, you can actually boot straight from the Windows USB, OS USB or ISO, whatever you're using for your image. Again, this is probably not the option you guys are looking for. We're really looking at how we're actually going to deploy using System Center or Configuration Manager. All right, so I kind of showed you guys this, but I wanted to make sure you guys could see it. This is with UEFI with the CSM implementation. The CSM is what we call the compatibility support module. That is basically the ability for the system to fall back and use BIOS. So there's code written into UEFI that says, if I boot the system and it's not able to utilize the UEFI components, go ahead and use the BIOS. Use the interrupt 19 to actually do the boot process. And you have that option available, and that's where you set it to using both instead of just using UEFI. If you're going to use UEFI, you need to set it to UEFI native mode. Okay, so let's go back to configuring the disk partition, and we'll walk through that process. I have a script, but I'm going to do this manually with you guys, and I will find the right switch this time. Yeah, no, it's the wrong one. All right. So, perfect. So I'm going to pull up. I have two USBs here. One is an 8 gig, and one is a 4 gig, I believe. And we're going to go ahead and create the 2 partitions that we need for the UEFI boot process. So normally, what you want to do initially is make sure that you've gone through the MDT process of creating your deployment you may make creating your deployment media or something that allows you to actually manage that boot process. So we're going to dive into one of my systems that have already MDT running on it, and we'll take a look at where we are with that. Let's see, pause critical, how much space do I have? Nice. So let's, 2 seconds, I will. All right. Fast-forward screen space. Okay, let's bring this back up. All right, so let's take a look at this system. I'm going to maximize this so everyone can see it. Screen. So what I have here is MDT, and we're in the process of looking at just the what you'd see with the MBR and the UEFI. So you have a couple of options when you're creating your task sequence. I'm going to go ahead and save this really quick, and then we'll talk about what your options are. So after you go through and create your image and you capture your image and you need to create your deployment for your task sequence, as we walk through it, the first thing that happens is it doesn't care. Let's go ahead and do a test, and I'll show you real quick. Win 7. Test. This one's going to be testing UEFI deployment. So I go through the normal process of doing a standard client task sequence. Click Next, select my operating system. It's already been imported. We'll go ahead and select this one for now, since we're going to take a look at that. We're not going to specify a product key. And we put in the password. Again, the intent is to show you what your typical the goal here is just to show you what your task sequence looks like when you first create it. Let's go ahead and take a look at this. And during your task sequence process, what you'll see is you start off with doing your pre-install phase, the new computer options of formatting the disk. And this is what you'll start off with normally. Now this is okay if you're gonna use a format partition disk. Now the difference is that MDT 2012 Update 1, it does a detection. It knows whether or not you're using UEFI. So it automatically knows exactly what it needs to do to ensure that it's converting it from MBR to GPT. We may have seen some of this earlier, but let's go ahead and run this manually. I'm gonna jump to the system itself. We're gonna actually execute the disk that will show the lighttouch. We're going to execute the lighttouch.vbs so we can take a look at actually where it's running that task. I can actually do it in the lab itself. Let's go ahead and open that up. I will find the file. We go here. See, just create, and the difference is if you're running on a virtual machine, you won't be able to see it. So you're literally obliged to make sure you run it on a physical system. Still this. So I've plugged in the physical system. I'm going to take a look at it here. And we're going to execute the light touch script itself, and we'll take a look at what it actually captures. So this is after you've gone through and created your image, but let's just take a look and see what we actually see. So it goes through, processes the LTI, the ZTI gather process, and it brings us to the task sequence options that we've selected. Now, before it even gets there, it's already done the analysis of the system. So let's take a look at the file itself, the OSD logs, and if we go into ZTI gather, we do a quick search for UEFI. The first thing we'll notice is that it's already evaluated whether or not my system is UEFI capable. let's see if I can find it here. Edit, find. There it is. So at that point, it's evaluated. So if UEFI is true, it will then format it as a UEFI disk. And this is where you'd actually validate that if for some reason you're having an issue. So I'm stating that to say that if you're using this process, that formatting of partition disk is just fine. However, if you want to add the Windows recovery or anything else onto that image, you might want to go in and edit this so that it's appropriate for whatever partitions you are using for UEFI. So I have here, I've started the process of creating my own disk with the formatting of the partitions itself, deciding whether to use EFI, MSR, and MBR. So EFI, usually, when we set this, these are the parameters that are used. We're going to set it as a FAT32. It's a quick format, and we make that a bootable partition. The MSR itself, same thing. Well, not same thing, but we set it as MSR, and it's usually around 128 megabytes. It's a hidden partition. You won't normally see it on your systems, but it's available. That's there to use as a scratch paste. And then whatever's left, you can actually use the primary partition as well. However, keep in mind that Windows will also create the Windows recovery partition as well. And if you're using BitLock or anything of that nature, you might want to be careful because you want it to be available on that recovery partition. So there are little additional extra steps that you have to do to ensure that you don't run into that issue.
Are there size recommendations or requirements for those various partitions?
So the question is, are there size recommendations or requirements? So the recommendations are, they're listed on the technical side, but usually we talk about 300 megabytes for the EFI system partition. Let me go back to it. And by default, you'll see a lot of this already built into the MDT. The built-in configuration are the settings, so about 300, anywhere between 100 and 128 would be what you'd set for the MSR itself. And then the primary drive is going to be whatever else is left. So you see here that it's set that way. As long as it has enough space to actually do its, to process what it needs to, it's usually fine. Okay, so let's jump back to the disk partition. I'll go ahead and format. I have two disks here, and I'm going to plug them in. We'll start with the boot disk. I'm not afraid to wipe it out. I'll just go ahead and do that now. So let's go back to list disk here. First, we'll go to disk part. That's very important. All right, and I'll list my disk. So I have the 4 gig disk. I have the 7 gig disk here, a USB device, and we'll start with disk 2. And the first thing you want, cell disk 2. And you notice I'm not typing the whole thing in. It just kind of saves time. I'm going to go ahead and list this one more time. So I have this 2 selected. And the first thing I want to do with this disk is to clean it. So I'm going to go ahead and clean it. So what that does is it wipes it clean, and it allows you to kind of start fresh with a clean disk that you can actually build. So then I'm going to create the primary partition. And it should be format. Sorry? I got to work on my spelling. Thank you. Well, that wasn't even it, to be honest. So, there you go. Somebody's thinking. Sorry. So let's just list here. So I'm going to just look at the commands because that actually makes sense. And we're going to do create partition primary. Let's go ahead and just find that. Okay, so I don't need to do that. I just need to do the create part pry. There we go. And then we're going to assign it. And then we're going to actually make it the primary the active drive. So now I have that as the active drive. Now I can actually go through the process of formatting that, that drive. So I equals at 32, quick, and label equals boot. One line, pretty good. Okay, so what it does first is it takes that first disk, that smaller disk, and it formats it in FAT32 because UEFI requires that FAT32 to actually do the boot. So if we take a look, now we have a blank disk that we can actually put our deploy files in, and I'll show you that in just a second. Let's go ahead and look at the second disk. Let's go ahead and create the second disk. So I have disk 3, which is an 8 gig disk. We're going to do the same thing. Oh, come on. Let's do this. There we go. Cell disk 3. Boom, boom. Okay, now I'm going to take a look at it. I already have it formatted. And I'm going to change it from what it was as a boot disk and make it a deploy disk. So this is the second disk, the USB device that I'm going to use. And I'm going to go ahead and clean it. And then I'm going to do the same exact thing. So create. And I'm going to assign it a letter for now. But I won't make it the primary. So that's the active drive. I'm just going to format it as MTFS. And I'm going to label it as deploy. Okay? So now I have two partitions. And what typically happens, and we'll just, while that's being formatted, not that that's the most important piece, what typically happens is when you create your deployment media, you end up with a pretty good size content that you have to basically do something with. It has to be placed somewhere. And let's see if I have it here. We'd walk through the process of creating that new media. Let me make sure. We'll close out of this. And you create that new media, and that's what you essentially would use to actually place into the OS, into the actual disk that you create. So I'm going to call this C:/media, and I can then select which drivers I want in there. For now, we're going to put in there all drivers and packages. We're going to go with just everything. Drivers and packages, all packages. So I need to create the drive. Let's go ahead and create the drive really quick. And what you'll see is the content, once you do the update of the deployment share, that content becomes part of that location. And that's what you'll use. So we're going to update the media content. And that's what you'll use to drive the population of both disks. So in here, you'll have your content, you have your deploy files, and you'll have the remaining files that actually need to go into the USB disk that you create. So let's go ahead and take a look at that. So the question was, does the whole deployment folder go into there, or the content? We'll take a look at that in just a second, and I'll show you. So let's assume that we've created that content, and it's all available in here. So I'm going to do the Martha Stewart method. We're going to jump right back over here to this side. So I have a disk that has the data in there already. And so I have plugged in another device exactly the same. So these two are the first devices we created. This is a Windows To Go device, which I have multiple partitions on. Same process with same type of data on there. So I have a boot device, a deploy device. So what happens is you won't be able to fit all of that data into a 4 gig, a 4 gig FAT32 device. You'll probably need to know exactly which files to actually put on there. So I'm going to So what you'll see when you're done with that process, let me just move some of these so I can kind of show you what you'll actually see, is so what you'll see is something similar to this. With your files, no, not the drivers. You won't see the drivers because that's personal to the machine. Where it doesn't care what's on there, as long as you have that boot deploy, EFI, and any of the auto runs, that becomes your contents drive. That becomes what's created when you get done with the actual process of updating that boot image, right? So it's going through and creating this as we speak. So in that media location, I have content, I have deploy, and it's going to create the rest of those files. And it relies on the fact that the Windows ADK has already installed the bits in the location, and if you're not sure, you can actually use those or the files from the Windows 8 OS to actually populate it. So you end up with this, and let's just take a deeper look into it. So EFI has its own structure that it actually looks at, and Microsoft has its own Hive that it actually relies on with the boot files in there. And as long as this is here, this is what it will use to find. And if for some reason it can't find this boot file, it goes back to the original Microsoft location. So it looks for this boot 64 EFI file. Let's go ahead and look here. And you see it all here. So what I'm going to do, what we want to do is we typically would take this and copy it straight to this boot device here. I don't have it here. Oh, that's the new one. Sorry, this is the old one. This is the original one that I had. So it's already been copied here. As you can see, I have the boot files. I've created the deploy folder with only the boot file, with the light touch WIM file. Again, you can have multiple files if you want, but you really don't need, you only need the one boot file that actually shows you what you have. This is one we use for the MSIT builds. And in there, I'll have my WIM file. And that basically is what that's what I would use to actually do the image build. And then lastly, the rest of the files go here. So you have your deploy. You can literally just have your deploy here. I tend to put the whole thing on here, but again, it relies on this boot file being available. So let's go ahead and jump over to this system, and we'll get right into the boot. I'm not going to do the whole build itself. I'm going to walk you through using this as part of your initial build process. All right? Hopefully you guys can see that screen. I'm going to go ahead and reboot this real quick. We'll start it up one more time. And again, the F12 becomes very important. We're going to bring this up. All right, so I'm going to select that FAT32 partition portion. And in there, we start that loading of that files and the actual boot deploy, the media that you had, that you made available. And this will get you to the point where you're actually loading that EFI drivers, loading the system, checking to make sure that it's EFI enabled, and actually going through to actually build the EFI system. All right? So at that point, once you get to this screen, that you've gotten past the requirements of using UEFI for your Windows 8 deployment. Because at that point, you would have had a screen that says, select which operating system you want to use. It's identified the fact that it knows what it needs, and it can actually move forward with the actual build of the operating system. Now, unfortunately, I'm not going to wipe my system because all my data is on here. But I wanted to be able to show you what you need to do to get to that state. From there, you select your operating system, you select, you do your task sequence options, skip password, whatever, and you move forward. And that gets you into your EFI system. So let's go back to the presentation. If I can get the right screen going. There we go. All right, so there's also sample disk part. So all that jumping around that I was showing you, you have a script that actually can do the same exact thing. And you can partition it. You'll notice a few really cool things. You can set the ID of that that partition so that it actually stands out. It's actually required that if you look at the WinRE tools, that you need that set ID as part of your script. So that text file basically is the recommended configuration that you would actually see for a GPT partition or a disk that you're using for Windows 8. The other side of this is using Configuration Manager for the MDT 2012. And if many of you guys went to the actual session with Johan, he may have shown you portions of this as part of what he was doing with his image, with Configuration Manager. So let's go ahead and take a look at that while we're here. I'll go ahead and open up my Configuration Manager. Go ahead and start it back up. Everything's stopped. And in here, I'm going to pause out of it. So as you're creating your task sequence, right? So I've already gone in and imported the OS image that I had initially. There it is. So I've imported this OS image, and then I've distributed the content to my DPs. I'm going to maximize it so you guys can see the whole screen. Good. So the next phase of this is really to create your task sequence. You can use an MDT task sequence, or you create a task sequence media. We'll go ahead and create an MDT task sequence. And we'll call this and you can specify an existing boot image package. We're going to use the 64 boot image. Or you can, if you have your MDT integration, you can actually use that as well if you know exactly where that is. And I believe don't have my hang on. So this phase will walk you actually. Screens are all over the place. So you can actually walk through the process of creating your task sequence so that you have the ability to import the operating system and use it as part of your task sequence media. So, I have the option of doing the boot image, or I can actually, let's go ahead and use the normal task sequence process, client task sequence, and I specify the task sequence that I want. I'm going to join a work group. Yeah. Thank you. And this, you can basically, again, this is more about what you would actually do if you needed to capture the image using the task sequence. I'm not really going to go through all the details. All I want to do is show you the fact that the UEFI is an option that's available as part of your task sequence creation process. And essentially, what you end up seeing is the drive configuration itself. Now, fortunately, I thought I had it in here already. I don't. I'm going to go ahead and cancel. And we're going to just create a task sequence. All right. Let's go ahead. I want to show you on the slide itself what I have so that we don't spend the time kind of mucking around in there. And what you'll see is, with the boot process, you'll see your partitions show up. You'll see that 128 megs, the Windows partition that remains the same, the MSI partition itself, all become part of your disk configuration itself. So this is what you'll end up seeing as you're building your image. And we talked about what's supported for UEFI, and I mentioned this earlier. In 2008, you have 64-bit that's supported for UEFI, and that was introduced as part of the 64-bit architecture for UEFI support. With 2012, you had added support, so you're going from not just UEFI, but support for 2.3.1c, which is the current standard. 2.3.1d is out as well. And then you also have added support for 32-bit UEFI deployment. So if you're using Pixie within your environment, make sure you're thinking about it from a support standpoint, that 2012 is probably the operating system you want to utilize. And lastly, if you're also going to utilize IPv6. 2012 is also a supported component as well. But keep in mind that if you're, depending on the type of version that you're actually using to boot from, if you're doing a 32-bit or a 64-bit, make sure that you're considering the architecture and the type of boot, the boot image that you're using. Because the 32-bit will create a 32-bit image. You need the boot drivers for those. And the 64-bit is supported for 64-bit. So this is what we were trying to get to show you, but this essentially is the same thing. You see that it's automatically created by default. There is a slight bug in there where you actually have to specify the OS disk as a variable so that it knows exactly which drive to actually load the operating system in. There's a few articles out there about it, but this is essentially what you see in your configuration manager deployment process. So I kind of went over that earlier. So getting into some of the boot times and the boot requirements, one thing you'll notice with Windows 8 as we kind of move into it is the whole boot process is much, much cleaner, much more reliable, and it eliminates the long-standing process of waiting for that system to boot. But there's another catch that we started realizing is people don't normally work with their systems in the off state, right? We always start, the things that we should be testing is the time it takes to actually restart your system. So the idea that your system is off is not as important as the fact that it's a really quick process from the time you restart that system to the time it comes back on again. And that's what we need to be measuring, as well as the hibernate phase, how long your system can go from a hibernate phase all the way back into your operating system. So you see a lot, going from Windows 7 to Windows 8, that gets cut down quite considerably. And part of it's because of the hybrid file itself, and the power on self-test process is just literally slowed down. The initialization, which also is also improved because of the drivers, the fact that we're using drivers, and the fact that you can use much more memory on those GPT disks as well, are also important factors to think about. And those things are enabled by default. So can you really tell a difference? This piece here is really talking about what we started seeing with some of the initial testing. I spoke with Michael Niehaus. We talked about kind of what the testing was that we noticed, and you're not seeing a whole lot of difference, but it's enough to think about where are we going next with this? What type of hardware are we working with? So that 40, you see you're going from a legacy boot of 50 seconds down to about 40 seconds, all the way from an OS to the summary of the installation wizard. That's still going from 50 seconds to 40 seconds. Again, this is some of the things that we were seeing with some of the older systems that weren't necessarily UEFI compliant yet. And then basically cold boot, how long it takes to boot from that system all the way up. So we see a native boot is up to about 27 seconds. So, and lastly, the hibernate, the time it takes your system to get out of the hibernation stage all the way back up into the actual operating system stage. So the last piece of this is talking about other UEFI specifications, the supporting factors for UEFI. So secure boot, and you probably heard some of this already in some of your other sessions. Secure boot becomes an important factor because we start talking about what's specified by Microsoft and what's specified by the UEFI. And the important piece here is understanding that in order to load an operating system, it relies on the certificate system. Just like you see in Active Directory where you have to have certain certificates to load certain components of the system. These binaries have to be trusted. They have to be signed off, not just by the OEM vendor, not just by Microsoft, but anything that actually hits the system needs to be signed off. That's where we're going with Windows 8 and the UEFI platform. So a feature we call secure boot is a UEFI specification. It's not necessarily, it's not something that is driven by Microsoft. So by the UEFI specifications, secure boot becomes a very important factor in ensuring that you can actually protect the operating system as it's being built as part of the process. So This also includes option ROMs, anything else that's needed to actually load the system, and you're going from just the platform keys, we call it PKs, to the key exchange keys, which actually also have to be signed, all the way to allowing and disallowing it using the database signatures that are available. So all of this becomes an option as you're using Windows 8. The fact that you're thinking about how secure your systems are, what's actually loading on it. So the other thing is, if you're going to dual boot systems, if you have a need to dual boot systems, think about the other operating systems and the fact that they're also going to require some level of certification, something that allows it to show that it's trusted as it's actually being loaded, so you can have a dual boot system available on those devices. But most important part is it allows for strong authentication and also ensures that you have a process to authenticate, go through the actual process of knowing that this system is doing the right thing, that binary is signed with the right hash, and that hash is located in the allowed database. And if for some reason that hash has an issue or has a problem, it'll probably end up in the disallowed location, where then it will prevent it from actually being loaded. So make sure you're aware of what's going on with your devices, as they're also required. Secure boot, again, it allows it to go through the launch verification process. So when you're using it UEFI and you have the native UEFI, it already does the validation, ensuring that you are going through the right process of securing that system. Windows 8 comes with it just by default, as I mentioned. Measured boot. So what measured boot is basically you have components that have to be validated before they actually can run, starting from the firmware down to the bootloader down to the kernel. So every component has a hash that's checked against before it actually gets passed over to TPM. It checks for the next oncoming component to ensure that it's actually secure and it actually can do what we need it to do. And all the way down to the port where you're getting the early drivers. All those components are checked against the measured boot process to ensure that it's okay and it won't have an issue, that it has the right driver signed to it. So you'll see that. And I mentioned this earlier again. So what it does is ELAM also is another piece of this that allows you to run anti-malware before the system loads up. It checks to see what's actually loading, and it's able to detect it before it actually starts. So with Windows 8 and Trusted Boot, with the trusted computing, what you have is the ability to sign those certificates and ensure that whatever you're running is caught before it actually gets to the OS. So we're protecting the system all the way from the boot process all the way to the OS with those signed signatures, and also being able to run any anti-malware on those systems before they actually get all the way up and running on the operating system. Again, this is just another way to ensure that we're doing things early enough during the process and ensure we're not going to have an issue moving forward. Many of you guys may be familiar with this architecture. Again, this is the full architecture of what the platform looks like for Windows 8, all the way from the process of starting the UEFI boot to the OS loader, protecting the OS kernel, and then the fact that the TPM, which isn't necessarily a requirement, but it's there because it protects the system and actually can do the measured boot, is available as part of the actual build process. And you'll see that it does if you have the client, it actually does the test and it does the validation that this service that's running or this binary that's running on the system is actually has the right hash, and it can actually do what it needs to as it loads the operating system. And it just proves to the client that the client is healthy and doesn't have an issue. Even to another step where it actually ships it off to another system to validate what's all the binaries that actually have loaded on the system and are they valid. Again, this has just been a piece that's been missing in the whole evolution of the operating system, the BIOS, upgrading the firmware to ensure that it's actually protected, and this slide would actually have shown it. Now, I don't have a demo for the secure boot, but I think, for the most part, I think you guys have a good understanding of where we're coming from in the secure boot. Frank probably has that demo. And so last piece here is the Windows support for UEFI. We talked about some of the highlights. Again, multicast deployments are available. You can actually use that as part of your boot process. You have fast boot and resume from hibernation. You'll start seeing that as an added benefit as part of your process. And in future, you'll probably see more with rootkit preventions and network authentication as an initial benefit of using UEFI. Again, this is the platform we're moving towards. You'll start seeing us move from what we call different classes of UEFI. So there's Class 1, Class 2, Class 3. Some of you may have heard of it. Class 1 is literally the EFI that was around in the early 2000s. Most of the systems we have now probably don't run it. The Itaniums that were first introduced probably were considered EFI Class 1 systems. The Class 2s are the existing systems that you probably see now where they have UEFI running on them, but they also have the compatibility support module that allows it to fall back and use the BIOS as part of the boot process. And that was the standard for quite a while. Now with Windows 8 and moving on forward, you'll start seeing a lot more with the Class 3 systems, which is basically there is no CSM, there is no fallback mechanism. It really is just running in UEFI mode, and that becomes the standard that you're able to use as part of, that's how it comes enabled. Obviously if you're that desperate, you could also go back into the BIOS, change it back and say I want to use legacy. But by default, it's shipped with UEFI as the standard. And that's where we're going with the Windows support module. So key objectives covered is just discussing the changes in firmware, demonstrations of using UEFI during the Windows boot process, and any enhanced features. That's it for the session. I don't know if does anyone have any questions before we get going? Go ahead. Can you head to the speaker so I can, or you can speak up. I'll.
We used to flash the BIOS at one time to upgrade. Will it be upgraded to UEFI, and how do we get them?
So the question was, you use the flash BIOS to get to UEFI, and the question is, will you have that available to use in the future? The answer to that is, you need to be able to talk to you need to be talking to your OEMs. One thing that you can do with UEFI is you can have, the vendor can provide you with ways to actually move into the, format the disk before you actually get to the actual use of the MDT tool. And they will provide you with that information so that you can actually do what you need to do. Now, let me end the session before, so really quick, there's a few breakout sessions, and this is available for you. If you're interested. I don't have any hands-on labs that are available. Just make sure you're doing the survey as well, because that's going to help us kind of move into the next phase. There's a few other track resources that are available. And again, thanks for coming to the session. I'm going to still take questions, so thanks for coming. Really appreciate it. But if you have questions, just step up to the mic, and we'll keep